According to the National Electrical Code, conductors of different systems, such as a 15 kV system and a 600 V system, are generally not permitted to occupy the same raceway unless specifically approved for that purpose or explicitly permitted by other articles within the NEC. In this scenario, where there's a project manager wanting to use 15 kV shielded cable for a 480 V application, along with other wiring that will be 120 volts or 480 volts using 600 V cable, all primarily underground, there are several crucial points to consider, even if the 15 kV cable will never be used for voltages over 600 volts. The 15 kV shielded cables must adhere to the requirements outlined in Article 396 of the NEC, particularly concerning raceway size and minimum cover depth, as detailed in Table 396.9. Simultaneously, the 600 V cables must comply with the requirements specified in Article 334 and Table 334.60, which also addresses raceway size and minimum cover depth. Beyond these fundamental code requirements, there are additional considerations to ensure safety and compliance. Firstly, segregation is paramount. The cables must be physically segregated within the raceway. This is to prevent any contact between the 15 kV and 600 V cables. Achieving this segregation can be accomplished by implementing separate compartments within the raceway, utilizing barriers between the cables, or employing spacers to maintain a safe distance. Secondly, grounding is crucial. The 15 kV cable shield must be properly grounded in accordance with Article 396. This grounding is essential for safety and to manage fault currents effectively. Thirdly, the raceway material itself must be suitable for both the 15 kV and 600 V cables. This includes considerations for voltage rating, temperature rating, and environmental factors, particularly since the installation is primarily underground. Regular inspections are also necessary. The raceway and cables should undergo routine inspections to verify they continue to meet the required codes. Furthermore, the inspection should confirm that there is no damage to the cables and that there is no unintended contact between the cables operating at different voltage levels. In summary, sharing the same raceway for the 15 kV shielded cable and the 120 or 480 V 600 V cable is permissible only when all of these conditions are rigorously satisfied. This includes strict adherence to NEC codes, physical segregation of the cables within the raceway, proper grounding of the 15 kV cable shield, selection of appropriate raceway material, and regular inspections to ensure ongoing compliance and safety. Failing to meet these requirements could result in code violations and potential safety hazards. Let's delve deeper into the specifics of each of these requirements to provide a more comprehensive understanding. Firstly, consider the NEC code requirements. As previously stated, Article 300.3 B dictates that conductors of different systems should not occupy the same raceway unless specifically approved. The key phrase here is unless specifically permitted by other articles in the NEC. This suggests that there may be specific scenarios or conditions under which the NEC allows for the mixing of voltage levels in a single raceway. It's crucial to thoroughly examine other relevant articles to determine if any exceptions apply. For example, some articles may provide allowances for specific types of equipment or installations. When considering the 15 kV cables, Article 396 is the primary reference. This article covers medium voltage cables 601 volts to 35,000 volts. Table 396.9 provides guidance on the minimum cover depths required for direct buried cables, which is particularly relevant for the underground portion of the installation. The cover depth is the distance between the top of the cable or conduit and the surface of the ground. This depth is critical for protecting the cable from physical damage, such as from digging or other activities. It's important to note that the required cover depth varies depending on the voltage level, the type of cable, and the presence of any protective measures such as concrete encasement. Additionally, Article 396 addresses the requirements for cable construction, insulation, and shielding. These requirements are designed to ensure that the cable can safely withstand the operating voltage and any potential fault conditions. For the 600-volt cables, Article 334 is the governing section. This article focuses on non-metallic sheath cable types NM, NMC, and NMS. While the specific cable type may vary depending on the application, Article 334 provides general requirements for installation, support, and protection. Table 334.60 outlines the ampacity ratings for these cables, which is essential for proper circuit sizing. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. Selecting the correct cable size based on ampacity is crucial to prevent overheating and potential fire hazard. In addition to ampacity, Article 334 also addresses the requirements for cable bending radius, support spacing, and protection against physical damage. These requirements are designed to ensure the long-term reliability and safety of the installation. Now, let's consider the additional considerations. Segregation is paramount in mixed voltage raceways. The intent of segregation is to prevent accidental contact between conductors operating at different voltage levels. Such contact could result in equipment damage, personal injury, or even death. There are several methods for achieving adequate segregation. Firstly, the use of separate compartments within the raceway is highly effective. This involves physically dividing the raceway into distinct sections, with each section dedicated to a specific voltage level. This can be accomplished using manufactured dividers or by constructing barriers from suitable materials. Secondly, barriers can be installed between the cables within the raceway. These barriers should be made of non-conductive materials and should be securely fastened to the raceway. The barriers should be of sufficient height and width to completely separate the cables. Thirdly, spacers can be used to maintain a safe distance between the cables. Spacers are typically made of non-conductive materials and are designed to provide a fixed separation between the cables. The spacing should be sufficient to prevent accidental contact, even if the cables shift or move slightly. Grounding is another critical aspect of mixed voltage installations. 15 kV cable shield must be properly grounded in accordance with Article 396. The purpose of grounding the shield is to provide a low impedance path for fault currents to return to the source. This helps to quickly clear any faults and minimize the risk of electric shock. The grounding conductor should be sized appropriately for the available fault current and should be connected to a suitable grounding electrode system. The grounding connection should be made in accordance with the manufacturer's instructions and should be inspected regularly to ensure its integrity. The raceway material must also be carefully selected. The raceway should be suitable for both the 15 kV and 600 volt cables, considering factors such as voltage rating, temperature rating, and environmental conditions. Metal raceways, such as galvanized steel or aluminum, are often used for high voltage applications due to their ability to provide shielding and grounding. Non-metallic raceways, such as PVC or fiberglass, may also be used, but they must be properly rated for the voltage and temperature requirements. The raceway should be installed in accordance with the manufacturer's instructions and should be adequately supported to prevent sagging or damage. Finally, regular inspections are essential for maintaining the safety and reliability of the installation. The inspection should be performed by qualified personnel and should include a visual examination of the cables, raceways, and grounding connections. Any signs of damage, such as cracked insulation, corroded raceways, or loose connections, should be promptly addressed. Electrical testing, such as insulation resistance testing, may also be performed to assess the condition of the cables and insulation. The inspection frequency should be determined based on the operating environment and the criticality of the installation. In harsh environments or critical applications, more frequent inspections may be necessary. It's important to document all inspections and any corrective actions taken. This documentation can be valuable for troubleshooting problems and for demonstrating compliance with applicable codes and standards. In addition to the specific requirements outlined above, there are several other best practices that should be followed when installing mixed voltage raceways. Firstly, always consult with a qualified electrical engineer or inspector before beginning any work. These professionals can provide valuable guidance and ensure that the installation complies with all applicable codes and standards. Secondly, use only approved materials and equipment. All cables, raceways, and grounding components should be listed or labeled by a recognized testing laboratory such as Underwriters Laboratories or Intertek. Thirdly, follow the manufacturer's instructions for all materials and equipment. This includes instructions for installation, termination, and maintenance. Fourthly, use proper tools and techniques. Electrical work should be performed by qualified personnel using appropriate tools and techniques. This helps to ensure the safety and reliability of the installation. Fifthly, label all cables and raceways clearly. This makes it easier to identify the different voltage levels and to avoid accidental contact. Sixthly, keep accurate records of all work performed. This includes drawings, specifications, and test results. These records can be valuable for troubleshooting problems and for future maintenance. By following these best practices, you can help to ensure the safety and reliability of mixed voltage raceway installations. Let's consider the implications of not adhering to these requirements. Firstly, there are significant safety risks. Failure to properly segregate and ground the cables can increase the risk of electric shock, equipment damage, and fire hazards. Secondly, there are code compliance issues. Violations of the NEC can result in fines, penalties, and even legal action. Thirdly, there are reliability concerns. Improperly installed or maintained cables and raceways can lead to premature failure and costly downtime. Fourthly, there are insurance implications. Insurance companies may deny coverage for incidents that are caused by code violations or negligence. Therefore, it is essential to take these requirements seriously and to ensure that all work is performed in a safe and compliant manner. Let's talk about the practical aspects of implementing these requirements. Firstly, planning is crucial. Before beginning any work, carefully plan the layout of the raceway and the location of the cables. Consider the available space, the required clearances, and the potential for future expansion. Secondly, coordination is essential. Coordinate the work with other trades, such as mechanical and plumbing, to avoid conflicts and ensure that the raceway is properly supported. Thirdly, communication is important. Communicate clearly with all personnel involved in the project to ensure that everyone understands the requirements and procedures. Fourthly, training is necessary. Provide adequate training to all personnel who will be working on the installation. This training should cover the applicable codes, standards, and best practices. Fifthly, supervision is crucial. Supervise the work closely to ensure that it is being performed correctly and safely. Sixthly, documentation is important. Document all work performed, including drawings, specifications, and test results. By following these practical steps, you can increase the likelihood of a successful and safe installation. In conclusion, while it is permissible to share raceways between 15 kV shielded cable and 600 volt cable, it requires strict adherence to NEC codes, careful planning, and diligent execution. The key elements are segregation, grounding, appropriate materials, and regular inspections. Neglecting these requirements can lead to significant safety hazards, code violations, and reliability issues. Always consult with qualified professionals and follow best practices to ensure a safe and compliant installation. In the specific scenario presented, the project manager's desire to use 15 kV shielded cable for a 480 volt application introduces some complexities. While the cable itself is rated for a much higher voltage, the fact that it will only be used at 480 volts does not negate the need to comply with the requirements for 15 kV cable installations. The NEC does not allow for downrating the cable and treating it as a lower voltage cable. The cable must be installed and treated as a 15 kV cable regardless of the actual operating voltage. This includes complying with the requirements for raceway size, cover depth, grounding, and segregation. The reason for this is that the cable's construction and insulation are designed for 15 kV, and the NEC requires that the installation be consistent with the cable's design. Therefore, even though the cable will only be used at 480 volts, it must still be installed in accordance with Article 396 and other applicable sections of the NEC. This may seem counterintuitive, but it is essential for ensuring the safety and reliability of the installation. The higher voltage rating of the cable provides an extra margin of safety, and the grounding and shielding requirements help to protect against fault currents and electromagnetic interference. In addition to the technical requirements, it is also important to consider the economic implications of using 15 kV cable for a 480 volt application. 15 kV cable is typically more expensive than 600 volt cable, and it may require more specialized installation techniques. Therefore, it is important to carefully evaluate the costs and benefits before making a decision. In some cases, it may be more cost-effective to use a 600 volt cable that is specifically designed for the application. However, if the 15 kV cable is already on hand, or if there are other factors that make it the preferred choice, it is essential to ensure that it is installed in accordance with all applicable codes and standards. Another important consideration is the potential for future expansion or changes to the electrical system. If there is a possibility that the voltage may be increased in the future, it may be wise to install the 15 kV cable now, even if it is not currently required. This can save time and money in the long run, as it will avoid the need to replace the cable later. However, it is important to ensure that the cable is properly terminated and protected, even if it is not being used at its full voltage rating. In conclusion, the decision to use 15 kV cable for a 480 volt application should be based on a careful evaluation of the technical, economic, and future considerations. If the 15 kV cable is the preferred choice, it is essential to ensure that it is installed in accordance with all applicable codes and standards. This will help to ensure the safety, reliability, and long-term performance of the electrical system. Remember to always consult with qualified professionals and follow best practices to ensure a safe and compliant installation. Also, make sure to always use the proper personal protection equipment (PPE) for any electrical work being performed. This can include safety glasses, gloves, and arc flash-rated clothing. Before beginning any electrical work, it's important to energize the circuit or equipment and verify that it is de-energized using a properly rated voltage tester. Lockout and tag-up procedures should also be followed to prevent accidental re-energization of the circuit or equipment. A job safety analysis (JSA) is also a good way to think through the whole project and figure out ways to keep you and your team safe. If working in a trench underground, make sure the trench is properly shored up to prevent collapse, and make sure you have a safe way to enter and exit the trench. It is important to stay hydrated and take breaks when working in hot or humid conditions. If you have any doubts about your ability to perform the electrical work safely, it's best to consult with a qualified electrician. Always remember that safety is the top priority when working with electricity.